Hello everyone, welcome to my YouTube channel Sanha Academy. If you are new here, kindly subscribe and hit the notification bell for more informative videos. This is the icon of the subscription button, and this is the ring bell for notification whenever we release a new video. So please kindly subscribe and hit the notification bell. Thank you. Our today's video is the continuation of the previous one on this topic, introduction to system programming, and the presentation outline consists of 4 items, which is number 1 is the concept of compiler, number 2 overview of interpreter, number 3 a difference between compiler and interpreter. Then the last one in the presentation for today is linker and loader. All of them under introduction to system programming, which is the continuation of the previous video. Let's begin with the number 1. Number 1, which is the concept of compiler. What is compiler? In short, compiler is used, or is a system software that is being used to translate a high-level programming language into low-level programming language, which is into a machine language. So when a user writes a code in a high-level language such as Java programming and want it to be executed, a specific compiler which is designed for Java is used before it will be executed. So the compiler scans the entire program first and then translates it into machine code, which will be executed by the computer processor, and the corresponding task will be performed. So a compiler is nothing but a system software that help high-level programming languages such as Java programming and other programming languages like Python, like C++, Fortran, COBOL, BASIC, C#, Perl, and etc. So all those kind of high-level programming language, compiler helps in converting them into a machine code. So before executing the code, a compiler has to compile the high-level programming language. So this is the concept of a compiler. And the concept continue. What is compiler? Compiler is a piece of code that translates the high-level language into machine language, like I explained earlier in the previous slide. In another definition, a compiler is a translator which takes input that is high-level language, such as Java programming, like I mentioned earlier in the previous slide, and produces an output of low-level language, that is machine or assembly language. So these are the definitions of compiler. So from the definition, you can be able to understand that compiler is nothing but a translator that can translate high-level programming languages into low-level programming language. You see, this is a high-level language, which is the source code of the programming language, whatever kind of the programming languages. Then compiler will compile this language into object code, which is the machine language or assembly language. This is the continuation of the compiler. How is a compiler is working? As this is the working process of a compiler. You see a compiler, and these are the source files, which is the high-level languages, and these are the object files, which is the machine language. So a compiler can accept the high-level languages like Java, C++, and compile them, which is translate this code into a machine code, which so that the machine can be able to understand the language, because machine can only understand binary numbers, but the code that are going to be written here is alphanumeric code, alphanumeric numbers, which is the combination of characters, letters, and numbers, but machine can only understand binary numbers. So compiler will help in converting this code or source files or high-level language into a machine code, which is a low-level programming language. Then the runtime library, this is the runtime library, linker, and the executable program. Because before this high-level programming language can be able to be executed, then a compiler has to translate the language into a machine code. Then linker will help in executing the program. That is all about the concept of a compiler. Then the next item in the presentation for today is interpreter. So what is the concept or overview of interpreter? Interpreters are not much different than compilers. They're almost the same. They also convert the high-level language into machine-readable binary equivalent. That means it can convert high-level programming languages such as the Java that I mentioned earlier, the C programming, into a machine language or low-level language, which is because the machine can only read binary numbers. So just like a compiler, interpreter also translates or convert high-level programming languages into machine language so that the machine can be able to understand. Then each time when an interpreter gets a high-level language code to be executed, it converts the code into an intermediate code before converting it into the machine code. Each part of the code is interpreted and then executed separately in a sequence, and an error is found in a part of the code. It will stop the interpretation of the code without translating the next set of the code. So this is how interpreters are working. Continuation of the interpreter. Sorry, this is typo. It's supposed to be number 2. So typing error. What is the definition? We can see the concept from the previous slide, which is this slide. The concept of interpreter, which we mentioned, is just like a compiler. So what is the definition? And the definition of interpreter is: an interpreter is a program that translates a programming language into a comprehensible language. What is the comprehensible language? The comprehensible language is nothing but a machine language or low-level language. So interpreter also translates or converts a high-level programming language into low-level programming language in a nutshell. Then it also translates only one statement of the program at a time, not like a compiler. Interpreters more often than not are smaller than compilers. So this is also the working process. This is how interpreter interprets high-level language into machine language. So we have a high-level language, a source code of any high-level programming language such as the Java that I mentioned, the C programming, and etc. Then interpreter has to interpret it, and so that the machine can be able to understand. But there is a slight difference between interpreter and compiler, and we can see the difference in the next coming slides. This is the working process of interpreter. This is the working process of interpreter. So interpreter, when it can get a word, and then if there is no more words, it will end. Then if there is word, then go on. Go number 1, then do recognizer, check state. Then you see compiler will compile, and the interpreter will interpret. So this is the working process of the interpreter. Then what is the difference between compiler and interpreter? Because from my previous slides I made mention that the compiler and interpreter are the same because they all use in translating a high-level programming language into a low-level programming language. But there is a difference between them, and these are some of the differences, about 10 differences of compiler and interpreter. Number 1, the compiler scans the whole program in one go, just one go, while an interpreter translates the program one statement at a time, not in one go, not just once. So it has to translate the programs or the source code one statement at a time. But compiler, in just a one go, it will just scans and compile the program. The number 2, as it scans the code in one go, the errors, if any, if there is any error, are shown at the end together. So if there is any error, you just scan everything in one go, but at the end of the running program, then you can see all the errors. Well, interpreter, considering it scans code one line at a time, so errors are shown in line by line, not at the end. Then number 3, the main advantage of compilers is execution time. But for the interpreter, due to the interpreters being slow in executing the object code, it is preferably less. And number 4, it converts the source code into object code. It does not convert source code into object code. Instead, it scans it line by line for the interpreter. Then for the compiler, it does not require source code for later execution. But for interpreter, it requires source code for later execution. Then number 6 is execution of the program takes place only after the whole program is compiled. That is for the compiler. But for the interpreter, execution of the program happens after every line is checked or evaluated. Then number 8, compilers more often take a large amount of time for analyzing the source code. In comparison with the compiler for interpreter, interpreters take less time for analyzing the source code. Number 9, it is more efficient. What is more efficient? Compiler. But for the interpreter, it is less efficient. The number 10, which is the last one for the difference between compiler and interpreter in this video, CPU utilization for compilers is more, but for the interpreter, CPU utilization is less. Why? Because this one execute line by line, but this one, after it finish compiling the whole program, then it executes so at one go. An example of compiler like C, C++, these are the programming languages that compiler based. But for Python, Ruby, Perl, all of them are high-level programming language, but this one are compiler based and this one are interpreter based. This is all about the difference between compiler and interpreter for this video. So let's see the next slide. Then the last item for the agenda is linker and loader. What is linker? We can see from the working process of compiler, we can see linker here. So after collecting the high-level programming language, it compile them into low-level programming languages, and linker will help in organizing the or low-level programming languages code before it will be executed. So linker combines one or more object files and possible some library code into either some executable, some library, or a list of error messages. So the task of integrating the program modules together is called linking. The task of integrating the program modules together is called linking. So you have a source code, then you have your compiler. Compiler will compile the high-level language. Then linker, the task of integrating the program, these program modules together is called linking. So it will link all the conversion of the compiler, then before it will be executed, to make it possible for the executable program. What about the loader? Loader reads the executable code into memory. So it does some address translation and tries to run the program, resulting in a running program or an error message, or both. So object program on secondary storage, loader, then object program in main memory. This is all about linker and loader. Thank you for listening. Kindly subscribe and hit the notification bell for more informative videos. Thank you so much.